Okay, in this video we're going to expand on some of the stuff we've learned with right angle triangle trigonometry. You can also use some sine rule and cos rule in some of these questions as well, and also it kind of taps into some of your angle properties. So we're kind of bringing it all together now to do some real applications of trigonometry. So this is about the angles of elevation and depression, which often refers to objects like aeroplanes which are in the air looking down at objects on the ground, or vice versa, where you're looking up at the air from the ground. So when we have an angle of depression, it's really important that we think of it as the amount that the person in the plane or on top of the cliff or wherever they are, how much they're tilting their head downwards from what we call the normal. So this is the normal here. All right, and it's the angle downwards. All right, it's very common for people to stuff up kind of which angle they're actually thinking about here. So it's from the point looking down, and then similarly, angle of elevation is the amount that the person down here would have to tip their head back to look up. And what we find is, and this is where angle properties come in, is that this angle is equal to this angle. So if this angle was, say, 30 degrees, this would be 30 degrees. So the angle of elevation is equal to the angle of depression. All right, for two objects which are looking at each other like that. So let's use an actual example to learn how to do these problems. So you'd often have a worded example, and we'd have to draw it from the words. So this one says a helicopter is flying at an altitude of 198 meters. At an angle of depression of 44 degrees to the landing pad. What is the distance between the helicopter and the landing pad? So let's draw it. So we've got point H up here, and we've got point L down here. Okay. So once you've done your diagram, you can see that we've created a right angle triangle, which is going to be useful in finding the distance here, which is D. Now, because the angle of elevation is 44 degrees, we immediately know that that's also 44 degrees. So we can use the alternate angles rule to fill in this one. And this gives us our right angle triangle here. And we're going to use that then with SOHCAHTOA. So labeling your sides, hypotenuse, opposite. We're going to use SOH. Okay, so a lot of us remember this as a kind of a switch that happens with the sine 44 and the D. When you're trying to find the hypotenuse, you kind of switch them over, so it ends up with this fraction. But if you look at the algebra steps, the first thing you're doing is you're timesing by D on both sides, and then you're dividing through by sine 44 on both sides. And obviously that cancels the sine 44, and on this side it cancels the D. So it's like the switch happening in two stages. But a lot of us can just remember the switching over. And that gives us 198 over sine 44, which you then put in the calculator. Making sure it says degrees up there. Okay, that's given me exact answer, so I'm going to press Control Enter for the decimal. Alright, and the question I believe said whole number, so we're looking for 285. So that's a simple version of an elevation or depression question, and here's an example exam question. So they've actually drawn it out for us. They haven't exactly asked us the same thing as above, so they've asked us for the gradient of FC. F to C, so we'll know that gradient is rise, which gives us one-eighth, which is 0.125, which is the answer that they're looking for. Now they want the angle of elevation from point C to F, of point C from F, so from F looking up there, so we're looking for this angle down here. Okay, so we've got our right angle triangle, we've got the opposite angle here, the opposite side and the adjacent side. So we're going to use that to use TOA, because we've got opposite and adjacent. So we're going to use TOA. So that means that tan of the unknown angle is equal to the opposite side, which was 50, and therefore the angle is tan minus 1, which means we do trig tan minus 1. Either type in 0.125 or you can type in 50 over 400, doesn't matter. It gives us an exact answer, so press Control Enter to get a decimal, and that's the angle there. Check that that says degrees, and they want to 1 decimal place, 7.1 degrees. Alright, now they want the distance, FC. Now this one you actually can either use Pythagoras, because you have both sides, or you could go and use a trig rule now that you have an angle. Pythagoras is going to give you your most accurate answer. So FC is the hypotenuse there, alright, which in Pythagoras we would call C, and then this is A and this is B. So remembering that C squared equals A squared plus B squared, that means that C squared is 50 squared plus 400 squared, so C is equal to the square root of them. Okay, press Control Enter for the decimal. 403.11, they want 1 decimal place. And that's an example of an exam question on this.